Ladies and gentlemen, thank you so much. Welcome to AMS Weather Band's latest webinar, Following Foliage, the Science of Fall Color. This is with Evan Fisher and moderated by Melissa Griffin. Now, before we begin, folks, I would like to address some of the rules for our webinar today. If you have any questions during the webinar, then please put them in the Q&A. If you look at the bottom of your Zoom screen, you'll see a Q&A button to the left of the chat button. That's where we would like for you to submit your questions. That is the place where we will be monitoring your questions so that they may be addressed during the presentation. Please do not put anything on the chat option. None of the comments or questions on there will be considered. We will also have time for specific questions as the presentation progresses. Evan will be able to field your questions as you put them in there. Melissa and I will represent you in asking the questions to Evan. So feel free to pack the Q&A with questions. All right. First, I would like to introduce today's moderator. Melissa, thank you very much for joining us today. Folks, Melissa Griffin currently serves as she served at the Florida Climate Center for 15 years, as well as the Kentucky Climate Center and the Kentucky Mesonet. Melissa has published peer-reviewed research papers on climate impacts on the southeastern United States, co-authored chapters of the book Florida Weather, and is involved in various weather-related outreach and education initiatives, including the CoCoRaHS Network. Melissa currently serves as the Assistant State Climatologist at the South Carolina State Climatology Office. So Melissa, the floor is yours.
Thank you very much, Gideon. It is my pleasure to introduce not only a colleague, but a good friend of mine, Evan Fisher. Evan is a senior at UNC Asheville's Atmospheric Science program and is a partner in the Foliage Report, which is the nation's most accurate fall foliage report in the United States. He's a local to the Southern Appalachians, and he's well acquainted with the particular timing of the fall foliage and also its intensity. His journey into fall foliage started in 2020 when he began developing 3D mapping depicting the average timing of peak fall color in Western North Carolina. And since then, he's branched out to fall foliage research and looking at remote observations, and has partnered with the Foliage Report in 2021 to produce national foliage maps for over 40 TV stations across the country. So it is my pleasure to introduce my friend to give this amazing presentation that I'm sure we're all really interested in. So Evan, I will give it to you.
Awesome. Thank you so much, Melissa, and thank you, Gideon, for getting us rolling and AMS Weather Band. This is going to be a really fun evening, and I'm looking forward to sharing all of the fall foliage goodness with everyone. So without further ado, we'll get into this entitled Following Foliage, the Science of Fall Color. So a little bit about myself, I'll be a little redundant here with what Melissa also said, but I am a senior at UNC Asheville studying meteorology in the atmospheric science program. I'm also a partner in the Foliage Report. This is a new development for me. I joined last fall and have been a part of the report since then. This fall, we've really been getting in depth into some remote observation networks and also releasing our weekly report of the state of the foliage across the United States. I'm also a winter enthusiast. Now, I know this is about fall, but truly, if you want to know about who I am, winter is my favorite season. So I look forward to the beginning of fall, and I look forward to the end of fall. And why fall foliage? If I'm a meteorologist, or at least I will be after next semester, why do I care so much? Why am I so invested in fall foliage? Well, like Melissa said, it all started with a map. So back in the fall of 2020, I was your typical college student trying to figure it out in the midst of the COVID pandemic and taking a gap year. And I stumbled upon this idea of creating a 3D fall foliage map, essentially overlaying expected date of peak leaf color maps onto 3D digital elevation models. It was very crude at the beginning. I believe this right here is one of my first maps that I think I actually made for Melissa back in 2020, and just kind of showing over a large area when the leaves would change color, when they would reach their peak color, and how that tied into elevation across these areas. Now, obviously, this was also, we know there's a latitudinal dependence for fall foliage changing and the timing of the peak color, but these early maps are very simplistic, didn't take into account any latitudinal variation, and were strictly elevation based. Since then, 2021, I learned a few tips and tricks in the off season and started making them a bit more high resolution. And nowadays, I'm making 3D foliage maps for tourism agencies across the Southern Appalachians, and having a whole lot of fun just creating plots like this and sending them out to the public, as they seem to be fairly informative. And I've gotten a lot of feedback. So as I got good feedback over the past couple of years, I kept getting more and more into this. And I wouldn't say fall foliage was an interest of mine 3 years ago. And then 2020, the only interest was making maps. I'm a meteorologist and a cartographer. But as this hobby grew and people wanted to know more, I decided that I also needed to know more, so I wouldn't be a bit of a fraud just making maps, not actually knowing anything about fall foliage. So that's my background. That's who I am. I'm a hobbyist, a meteorologist. I'm not a biologist or a phenologist. So the studying trees and leaves is not my specialty, but I'm going to do my best to be intersectional tonight and guide you all through the intersection between meteorology and phenology. So the reason why we're all here, why do the leaves change color every fall? Well, there's a couple of things that play into this, and I'll list them here. The two big players, a loss of daylight and cooler temperatures. These items trigger the leaves to begin to change their color, and it's why we see that transition from the deep greens in summer to the yellows, oranges, reds, and purples in the fall. If we lean into the first one here, a loss of daylight, we can see that obviously there's a latitudinal dependence that I mentioned earlier, where the higher latitudes, northern United States, loses a lot more daylight in August, September, and October than the lower latitudes do. This is kind of a basic model that helps us understand why the leaves change so much earlier in the north than they do in the south. And this is just a great starting point. So as the daylight begins to wane, first up north and then to the south, we see a slowdown in the photosynthesis process. There's not as much chlorophyll being created. And what chlorophyll is a chemical essential to the photosynthesis process. All of this is needed for creating food for leaves, and this is how trees sustain themselves. So with less daylight, there's less chlorophyll and less photosynthesis, and the trees begin to wind down for the season. They know it's time to start preparing for winter, and it's time to start conserving their energy. So as this chlorophyll breaks down, we also see a loss of green color. Well, why might that be? It's actually because chlorophyll is the chemical that is dominant in the leaf throughout the spring and summer, and it's also the chemical that gives leaves their green color. So because it's dominant, yes, there are yellows and there are oranges, orange chemicals in the leaf throughout the spring and summer, but this dominant green chlorophyll keeps those yellows and oranges masked so that we don't get to see them until the daylight begins to wane and the chlorophyll begins to break down. Now, it's dominant all throughout the summertime, but once this breaks down, we do begin to see that change in color, and that actually leads to the carotenoids and the xanthophylls, which are the yellow and the yellow-orangey chemicals. They become the dominant chemicals within the leaf, and we see that change in color. You'll also see here, I've listed anthocyanin. That's the red-producing chemical. And what's interesting is that it's not actually in the leaf in the spring and summer, like the carotenoids and the xanthophylls. It is not produced until the fall, and it is directly tied to the weather, not the daylight. So you can kind of separate these into different groups, where the yellows and the oranges are a result of a loss of daylight, but the amount of red that we see each fall is directly tied to what kind of weather we have in the fall. So transitioning into the impacts that the weather has on fall foliage, we can look at September as kind of a generic month, the start of fall foliage season. We see that there's a huge drop in average temperature across the United States, particularly in the east and the north. And this is what triggers the leaves to begin to produce their anthocyanin, and it begins to create that red chemical that mixes with the yellows and the oranges. And so as we see that temperature fall on average 6 to 14 degrees across the United States in the month of September, these chemicals become the dominant ones and the trees begin to prepare for winter. We also know the intensity of the fall color is directly tied to the weather because of this production of the anthocyanin. If that were not produced, we would have a much duller and a much duller fall foliage season. The intensity would not be nearly as bright. So that's how all of these things tie together. Obviously, the production is particularly susceptible to fluctuations in the weather. It can be just a period of 1 week where we have inhospitable weather, anomalous heat or rain or extreme cold. 1 week can completely derail a fall foliage season. So that's comes into play big time when we're forecasting for the fall. Now, why do the leaves actually fall off the tree? Well, we see as the temperatures cool and the trees have been triggered to begin their preparations for winter, there's actually a layer of cells that begins to grow between the tree and the leaf. At the base of the stem of the leaf, we see that layer of cells, and the tree is essentially trying to close off these veins that carry the water and the nutrients and preserve its energy and nutrients within itself. So that's why it creates that layer, and as that layer thickens, we begin to see that leaf weaken and die, and then it eventually falls off the tree and flutters to the ground in a rather awe-inspiring event for us, but perhaps a sad one for the tree. Now, if we look at the season itself, and we're looking at the weather's impacts on the fall foliage, there's two distinct periods that we want to eyeball when we're recognizing whether or not it's going to be a good season or a bad season for fall foliage. The first is March through July. We're going to lump spring and summer into one here. There's a short list of good things and a slightly longer list of bad conditions for fall foliage. Ideally, if you want a vibrant, intense fall that's long lasting and doesn't change too quickly, you want a warm, wet spring that allows for the production of the carotenoids and the xanthophylls and healthy leaves. You also want favorable summer weather. So you don't want to see any drought any time of year. Drought is all around bad for the leaves. It stresses out the trees and results in dulled colors. And you also don't want to see anomalous cold that can hinder the production of chemicals as these leaves and the trees ramp up for the summertime. Then later, the second half of the period, as we get into August and October, we're starting to look at the real-time impacts. So we're looking at how is the weather impacting the production of anthocyanin. And essentially what you need is warm days, cool nights, and dry weather. That's the secret sauce for great fall color. So you're looking for those days, especially across the east, maybe in the southeast, highs in the upper 70s, lows into the upper 30s, low 40s in the northeast, and maybe even a touch cooler. But that's the perfect weather for keeping the trees healthy and preparing those chemicals as the season progresses. As you can see on the right, there's a much longer list of variables that are bad for fall foliage. It's really easy to derail a season. Hot weather, warm nights, cold weather, heavy rain, drought, high winds, all of these variables can derail a season in the span of just 7 days. It doesn't have to be weeks or weeks on end. It can be a short event, especially with wind. I mean, one big windstorm as the leaves are beginning to change their color could quickly bring an end to the season before leaves even reach their peak. And so I kind of put together a bit of a cheat sheet here for the things you should be wary of going into the fall. Some sensible and negative weather impacts. As I mentioned, the heat and the persistent rain, these two are going to result in a delayed change, a later peak in the color, and also duller colors overall. Likewise, we also have a sub-freezing cold threat. This similarly dulls the colors and can also lead to a quick early leaf drop as the trees are shocked into creating that layer of molecule, the layer between the tree and the stem of the leaf itself, and quickly those leaves fall off and die. Likewise, heavy winds, high winds, and heavy rain, these actually have similar impacts, high winds, heavy rain, in that they can both knock the leaves off the trees. We think about that often with high wind, but we may not always expect that with heavy rain. But the heavy rain pounding against the leaves, especially when that connection between stem and tree is weakened, it can quickly knock off a full set of leaves on a tree in just one night. So moving into some observing networks, now we understand the science of why these leaves change, what could hinder the change, and what impacts the intensity of the fall foliage. But there's a lot of trees in the country to be aware of, and we always want to be observing all of these areas that perhaps are in the backwoods of the mountains. And maybe you're planning a trip to go up to. I'm from Asheville, Southern Appalachians. Maybe you're planning a trip to go to see the Appalachians and you don't know whether or not the trees are turning and the colors are progressing. So that's why we have these observing networks in place that are great and useful for getting an idea before you make your trip plans. So obviously there's no substitute for public reports. There's the highest density report system in the United States. There are millions of people across the United States, just like myself, that love to share the pictures of the trees in their backyard on social media, via email to TV stations. This is just the best way to do it. TV stations, like I mentioned here, are particularly adept at drumming up these reports. And they can put out a request for what the leaves are like in their area, and they can get dozens of responses, sometimes even hundreds, very quickly. So there's no other observing network that's as dense and as easy to access as public reports. Obviously, there's one drawback here. I'm guilty of this as well. But folks love to share the pictures of the brightest maple in the grocery store parking lot. And there's nothing wrong with that. That tree is beautiful, and I love the red maples that pop up around town in late August and September. The problem is we don't want to trick ourselves into thinking that the foliage is at peak color, when in reality, it's just one tree and one parking lot that's actually at its peak, and everything else around is green. So you have to balance that and understand, well, is this a maple? Is it in a parking lot, or is it close to concrete or man-made objects? Well, then it may be turning early. So we always have to be wary of that. And there's just one beautiful red tree out in the sea of green. It's also this other network that I love. I've been a huge fan of this over the past few years, and they're called phenocams. So this is a webcam network. It's national, and actually it's international, but they have hundreds of webcams all across the world focused only on looking at trees and ecosystems and some agricultural aspects as well. They'll look at a tree and take a picture of a tree every hour for years on end. And while this may sound very dull to some people, it's actually extremely useful when it comes to archiving what fall foliage has been like in the past, and understanding how weather impacts of previous years, how that weather impacted the progression of foliage in those years. There's some drawbacks with this. First and foremost, you only get a limited field of view. This webcam is looking at one tree for years. You don't get a ton of variety. And if that one tree happens to be a maple in the middle of a parking lot, as one of the phenocams here in my area does, well, you have to just go off of what that one tree in one parking lot does. And typically it turns early. There's also a very spotty coverage, which you can see here. This is a map of all the phenocams in the lower 48, and this is a good resource, but it's far from widespread. You're only going to see these cameras show up in strategic areas, and there's a lot of these spots, like the Adirondacks, may only have one camera. The Southern Appalachians only have 2 or 3 cameras if you're lucky. So it's tricky. You have to make use with what you got, and kind of settle with what's already there. You also have to be careful that these cameras tend to expire, and sometimes it can be sudden and you don't realize it unless you really get into the metadata of the camera itself. But these may stop taking an image, may have stopped taking a picture last October in Michigan. And if you were to pull that webcam up today, it would still show that bright color from last October in Michigan, even though, let's say, it's still green there. It's green there this year. There can be that disconnect where you could mistake last year's images for this year's. And there's a URL there at the bottom. I'm gonna leave that up for just a second in case anyone wants to take it down while I get a sip of water. Okay, so here's an example of what a phenocam looks like. This is a camera in Eastern Canada and a time lapse from 2021. This is a pretty brilliant example. It shows you the progression from green, little to no color, to high color, peak, and then how quickly the leaves fall off the trees. So this is clearly a very useful resource. It's just a matter of finding one in an area that's useful for what you're needing. These can also be analyzed. You can analyze the amount of red or orange or yellow in this image and track it throughout the fall season. So some work I've been doing recently has been looking at a camera here in the Southern Appalachians and tracking when the amount of red peaks in that camera image every season. So while this is not well labeled, you can see each of these peaks corresponds to the brightest color in that tree each year. So as they ramp up, that's the red becoming more and more prevalent. And then as they ramp down, that's the leaves falling off the tree. And you can see some years like the orange here, 2017 had an early start and then a delay because of some hurricane and extended rain, and then a secondary peak as oaks and the weather became a little bit more, the oaks began to peak and the weather became a little bit more favorable. You can see the timing of this peak, the peaks vary from on the order of a couple of weeks, from very early to very late in the season. All of this is related to weather impacts. Obviously, we lose the same amount of daylight every year at the same time, but this weather fluctuates, and that's what changes the timing of our peak intensity. We also have satellites. Satellites are quite useful. A couple that came to mind when making this presentation was MODIS and Sentinel-2, but these aren't always thought of as great resources because they're so far away from what they're observing. But MODIS and Sentinel-2 have high enough resolution that they can actually resolve the change from the green to the oranges and reds throughout the country, and they cover the globe. So they're pretty useful. One drawback right off the bat that I deal with the most is clouds. Oftentimes, I'd say half of the images you're going to look at, if not more, are going to have clouds in the way, and you can immediately throw that one in the garbage. There's no use in looking at that photo because all you're going to see is white and you can't tell how the colors are changing beneath. Another tricky one, which I'll give an example of in a second, the algorithms that are used to derive true color in a satellite image oftentimes misrepresent what the fall color actually looks like. So what could just be a nice moderate color with greens mixed with oranges down in the canopy may look like bright red from a satellite. So you have to be wary and be on guard when sorting through these images to and always ask yourself, is this realistic? Does this make sense with what the surrounding area looks like and where with where this camera or with where this location is in the grand scheme of latitude. Also, especially with Sentinel-2, there's infrequent sampling. So we may only get a non-cloudy image once every 2 weeks, if that, and we may only get, even with the clouds, we'll only get images every few days, if not a bit longer. So that can limit how much of how effective our time series are when comparing one satellite image to another and trying to track fall color throughout an entire season. Here's an example of the algorithm perhaps resolving colors incorrectly. So this was some fall foliage in Southwest North Carolina last year. And it's a kind of just a transition 2 weeks apart or so. The first image was taken October 23rd, the second image November 10th. And the first one, this green color, looks like what you would expect fall to be. Some oranges starting to creep down from the high elevations, but primarily green all throughout the valley. And then the second image on November 10th is red everywhere except for the grass in the fields. That's concerning to me. This is not representative of what the fall color actually looks like. If it was, this would be the best foliage season ever. But these reds are not realistic. And this is just an issue with the algorithm not understanding and not recognizing these colors correctly. And perhaps even in the higher elevations, picking up on areas where it's brown and reading that as an orangey red kind of rust color. Here's another example. This is, I just downloaded this yesterday, actually. This is some foliage in the UP up in Michigan showing the progression over 4 days. So the less bright image that you're getting ready to see right here is from 4 days ago. And you could see mostly green, some yellow showing up. But then we got lucky and had 2 cloudless passes from Sentinel-2 in just a 4-day time span. And you can see 4 days later, my goodness, the greens had transitioned into yellows and oranges and reds quickly. So we're seeing that peak color transition rapidly in the UP this year. Another one that I'm a little partial to and a little biased towards, the foliage report. So this is pretty cool. I joined into the foliage report 2 years ago. I'm partnered with this guy named Kyle. Kyle is awesome. He is the founder and owner of Foliage Report out of Texas, and he has this knack for going over dozens and dozens and dozens of resources. There's regional and state and local foliage reports that are out there. So people are reporting what the foliage is like, perhaps in their county or in New York as a whole, or you don't see too many regional ones, but I suppose there probably are some regional reports that you could find out there as well. And Kyle is exceptionally good at going to each of these reports every week, getting their update, and then kind of combining them in with his own expertise, with his own social media sleuthing and the reports that we receive, and creating a weekly report, a report on the state of the foliage across the United States. Thankfully, we don't have any competition in this, aside from some occasional reports from media, but we're the only consistent weekly report. So we also get to call ourselves the most accurate one, which is great. But truly what we do is exceptional, and Kyle has been doing this for many years, long before it even came to light on social media. So I like to think that the Foliage Report, with got a little @ there for our social medias, I like to think that this is arguably the best source in the United States for what the foliage is doing on the big picture across well, the whole United States. We do produce KMLs every week. So if you're a TV meteorologist and listening to this, our reports, which I'll show an example of here in a minute, our reports are available in KML format, and we can send a pre-styled KML every single week to you if you want to make a map with it. It's a lot of fun. I know I'm partial to that because I'm a cartographer and just love making maps. But KMLs are super easy, and you can load them into your TV or the software that you guys have at your station. So transitioning into our next topic, fall foliage climatology. Obviously, as we've talked about, these leaves change at different times depending on elevation and depending on latitude. So we want to know what's a good baseline for when the leaves are going to reach their peak color across the United States.
Excuse me, Evan.
Yeah, go ahead.
Yeah, sorry to interrupt, but before we move on, I wanted to ask a question that was posted by Janet, if I may.
Yeah.
So Janet asks, who decides where the phenocams are located?
Ooh, yeah, that's a great question. So they serve different purposes. So some of them serve strictly agricultural purposes. Well, I've never been involved in the decision-making behind the placement of a phenocam, but I believe my understanding of it is that if you have a need for it, you can buy a webcam and install it and connect with this network. So you'll see some at private farms, you'll see some at research centers, and you'll see others that seemingly don't have much of a purpose other than to look out over a valley of leaves. So my understanding of it, as I said, is just if you have an interest, you can probably go to that website that I linked there and join in and create and upload your own phenocam.
Cool. Thank you, Evan.
Yeah, absolutely. So moving forward with the climatology of when the leaves change, this is the map we put together this fall, the Foliage Report. And I believe it's one of the more high resolution average timing of peak fall color maps that's out there. I've yet to find one that's more high resolution than this in terms of terrain consideration. But we do see the earliest, the colors that change the earliest are in the northern tier up in northern Minnesota, Wisconsin, the UP. We also see early colors in the Northeast, And you can see the terrain that really shows up in the Appalachians down into West Virginia and Western North Carolina, as you do see some peak color showing up in early October. We're in that now. The first mountains here in the Southern Appalachians have reached peak in the last couple of days. The Northeast is reaching peak now. The northern tier is at peak and probably will be for the next few days. So this, we're seeing these average timings actually play out in many places this year. Out west, there's a lot of terrain variation. So the higher elevations above 9,000 feet in the Rockies are seeing peak color right now, whereas the lower elevations, especially down into Utah and New Mexico, Arizona, some of the lowest elevations there, particularly New Mexico, may not see peak color until early November. So there's a lot of variation there, and that's a reason why you can't generalize average timing over a large area, because you do have to be considerate of that terrain variation. Now, all the timing of this is what we talked about earlier. It all comes down to the loss of daylight and the progression of rapidly cooling temperatures and dry weather, if you're lucky, going throughout the fall. So that's kind of what all goes into this average timing. There's a great resource out there. I see it a lot every fall. It's called the Smoky Mountains Fall Foliage Prediction Map. I love it. I don't always love it, but it's a good baseline for fall foliage prediction. I don't know of any other websites that actually create a prediction like the Smoky Mountains Foliage Prediction Map does. They produce, I believe it's a weekly forecast. They'll make their forecast in very early fall, late August, early September, and you can see what the leaves are predicted to be like and what stage they'll be in as you go throughout the fall and head into November and peak season. Now, I've said I love it. There are also issues that you have to be aware. As I mentioned, there is the terrain generalization over these large areas. So you'll have counties out west where you see past peak color here predicted on October 17th, but this entire county is not at high elevation. Perhaps there are some mountain peaks within it that will be past peak, but I would wager that the large portion of that county is actually a lower elevation area that won't see color change that early. So they face the challenge of generalizing topography on the county level, which is not easy. And what they do is useful, but you just have to be aware of that drawback. I've actually highlighted a few areas here where you can see some of the troubles with that. October 17th, we certainly don't see any peak color in northern Georgia, but there are a few high peaks there that are likely triggering that to say peak color. Likewise, we don't see any high color near peak in eastern North Carolina. I'm not sure I could explain that one, but we do see similarly with the terrain issue, eastern Tennessee, peak color showing on October 17th, when in reality, it's only the high peaks, maybe above 3,500 feet in the Smoky Mountains there that are actually reaching that peak color, and low elevations where everyone lives are generally just in moderate color, if they're lucky at that point. And out west, as I've previously mentioned, a lot of variation, a lot of terrain smoothing and trying to generalize to the county level that just, it's a challenging thing. So what the Smoky Mountain Fall Foliage Prediction Map does, it has value. You just have to look at it through a lens of understanding that there are errors due to terrain smoothing. Speaking of that terrain, been talking about it a lot. How much of an impact does it have? Well, here in Western North Carolina, I live in Asheville, which is down around 2,000 feet. 20 miles away, we have Mount Mitchell, the highest mountain east of the Mississippi. That's up at 6,684 feet. So about a 4,000 foot difference in elevation there. Only 20 miles apart, but we'll see the leaves peaking and are currently seeing the leaves peak on Mount Mitchell in early October. But we won't see that peak until mid to late October down in let me make sure I can hide there we go, until late October down in Asheville. So this is a short distance, only 20 miles, but this terrain has a significant impact on when the leaves are actually changing. So you just have to be aware of that, like I said, when making your predictions and your forecasts. This is also useful for those who want to visit the mountains. Obviously, I think most folks probably understand this, but if you want to see the best colors early in the season, go to the high elevations. If you're going later in the season, stick to the lower elevations. My personal bias, if you're coming to the Southern Appalachians, is the mid-elevation peak. That's when you have the brightest, most widespread colors. It's not isolated to the top. It's not isolated to the highest mountaintops, and you don't see that leaf drop already up there. So when that mid-elevation is in peak, that's really when everything is perfect. See if we can get the slide to change here. There we go. A warning, please, 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 I'm begging, do not look at the Farmer's Almanac for fall foliage timing in the South. There has some accuracy in the North. I've gone through every single state in the Farmer's Almanac and looked at their forecasts. The North and the Northern tier are generally accurate. The South is a terrible forecast. It's just not accurate. You wouldn't use it to forecast the weather. We don't look at the Farmer's Almanac a year ahead and believe that there's going to be a blizzard on Christmas Day. So please don't use it to forecast the leaves, particularly in the South. Where I am in North Carolina, the leaves will not be peaking in inland North Carolina in mid-October, despite what the Farmer's Almanac will have you believe. That inland locations in the Piedmont are much later than peak much later than mid-October. So our final section here, we're going to go over just a few fun data visualizations that I've seen over the past couple of years, a couple of them that I've made and some others that I'm seeing others develop. So we'll hop into those if there are no questions. So the first is Curtis. Yeah,
Evan,
go ahead.
If I may, there's a couple of questions that are on the Q&A that I'd want to ask. The first one is from Rick, and this goes back to the presentation of the phenocams. Rick asked, the phenocams had different colors. What do those colors mean?
Yeah, that is a wonderful question. So they correlate to different types. Obviously, I'm sure you can discern that. I couldn't tell you exactly what they are. If you go to the link that's right here and click it, you can click on each of those icons, and it'll tell you what the difference is. I'll tell you, I've never actually noticed a difference. I've been using these for 2 years, and I can't tell you what the different colors mean. So it's not significant. I would say maybe a third of the ones that you see on this map are no longer active. There's new ones coming online all the time. There's old ones going offline all the time. So that's kind of the biggest driver here. I'm not sure what the reds, the yellows, and the greens stand for. They all take pictures at varying times, typically once an hour. I presume, if I had to make an educated guess, some of the colors, the greens are probably taking pictures of large scale foliage. The reds or maybe the yellows are agriculture focused, and whichever one is not agriculture is something else.
Excellent. No, thank you, Evan. And another question, if I may.
Yeah.
So Sarah asked, what is considered high, mid, and low elevations?
Yeah, sure. So that's going to vary throughout the United States. On the East Coast, I would say we can probably generalize it, and that high elevation is above 4,000, maybe 5,000 feet. We don't see the Appalachians getting any higher than 6,600 feet. So anything above 4 or 5 is generally high. Mid elevations, now you start, let me back up. You don't see any towns in the high elevation, save one town in North Carolina, the highest town east of the Mississippi. That's technically high elevation. It's above 5,000 feet, but very few people live up there. Down into the mid elevations, you're 3,000 to 4,000-ish foot range on the East Coast. It's where you start to see some people are living there, but still your densest population centers are below 3,000 feet. Below 3,000 feet is what I would consider to be low elevation. Once you get out into the plains, like the Piedmont of the Carolinas or the coastal plains, there's much less variation in topography and elevation. So I don't really consider there to be much high elevation and low elevation out there. It's just a gradual slope that you recognize. There's a very gradual change across that slope and foliage timing, but it's not nearly as sudden a change, as sharp a contrast as you might see in the mountains. Out west, I would perhaps say high elevation is 9,000 feet and above. Mid elevations are 7 to 9,000 feet, and below 7,000 feet is low elevation. That's definitely too general. I'm thinking specifically Colorado with those elevation limits. Yeah, it varies from place to place. You just have to consider what your highest elevations are, what the tallest mountain is in your area, and then kind of split that and the lowest elevation, and split it into thirds.
Great. No, thank you, Ben.
Mhm.
Thank you.
Yep. All right. So I'll move forward with our final section here. Popular data visualizations. So this one comes courtesy of Brad Panovich at WCNC in North Carolina. I worked with Brad a couple of falls ago to create an elevation-based KML, where these purple colors that you're seeing are the high elevation areas. These oranges and reds are the mid elevations, and the light orange bordering on yellow is the low elevations. And this was essentially just a way of visualizing how, let me see if I can get this to pause so we can take it all in. There we go. This is essentially just a way of visualizing how that fall foliage timing progresses as you go up in elevation. So you can see here, we see peak in these purple areas in the first 7 days of October, and then we don't see peak in these lower areas until the second half bordering on the end of October. So there's a lot of variation there. So this was just a unique spin on the 3D foliage maps that I create, but using a KML and done on the TV side of things with TV software. So that TV software is not available to everyone. And in fact, I've never even used it, which is why I've got a big question mark here. I use QGIS to create a KML like you're seeing here. And that KML is essentially just an elevation file, a file that has information about how high the mountain is in certain locations. And then Brad has fed that KML into his system and essentially overlaid it onto a Google Earth type software to create the illusion of 3D fall foliage map. Here's a static one. This is more like what I make. In fact, this is actually a map that I made this fall for the Asheville area. Again, 3D fall foliage, just illustrating how the leaves change earliest in the high elevations and later in the lower elevations down here in the valleys. This has big impacts for tourism agencies. So I work with a number of tourism agencies across the Southern Appalachians, and they want to know when the leaves are going to change in the higher elevations and how that relates to what hikes are in the higher elevations. If you're like me, I love to go up to the mountaintops to go walk through the peak fall color in October, but you need to know when that specific mountaintop is going to be at peak color. So that's generally the idea with these 3D maps, is to call out a couple of popular hiking locations here in the Southern Appalachians, the Cracky Gardens area, Mount Mitchell, a couple of these locations that are in the purple zone. So just kind of providing a little more information about when you can expect leaves to peak, instead of having to go off the generalization of, oh, leaves will peak in October, and then guessing and winging it. The next is, well, that's true. The tools I used here, like I said, for the last one, I used QGIS to do the elevation work and all the coloring and shading. If you're not familiar with QGIS, I'm realizing I've said it twice and explained it. GIS is a geospatial information service. It's essentially just a way of mapping and doing cartography. QGIS is a free open source version of GIS, and a great alternative to another version called ArcGIS. So I use QGIS to do all the coloring and shading here. And if you're interested in making one like this, I also use Blender to extrapolate 2D map into 3 dimensions. So when this map is at its most basic level, it's only the coloring and there's no 3D rendering. And then I just feed it into Blender and have it push up the mountaintops, essentially, create a 3D version. The next is a foliage report from a couple of weeks ago. This is two reports back, but just to showing what we do at the foliage report. This is how we generally look at areas. So we break it down. We do have a nationwide map, but we also like to break it down into regions. And this is just the Northeast showing what the state of the foliage is on September 26th in 2022. So obviously, as we progressed into this week, there's a lot more high color, more peak color, more moderate color. And you start to see this progression of the season. So this is just this is a state of what things are like currently. This is also using QGIS to create a KML, which I've mentioned before. I can send out, we send out to the TV stations, and PowerPoint, good old trusty PowerPoint that I'm in now, to illustrate everything and add all the text in. And I believe this is the last one. This is someone we've partnered with at the Foliage Report this fall, Weather Nation. We are sending our KMLs to them every week, and they're creating these really cool national visualizations of the current state of foliage. So I won't spend too much time on this one because it is the same as the last one, just on a national scale. But this is from the Foliage Report side of things, what we offer behind closed doors, something that we don't necessarily post on social media, but this is the data that we have on hand that we send out to TV stations. And if you wanted the data for yourself, I know I've pitched this to TV meteorologists already, but if you were to want the data, the KML for this map yourself, and you're familiar with that and QGIS or ArcGIS, I could certainly send that out as well. QGIS here once again, and whatever TV software Weather Nation uses to create this lovely map with all the city labels and coastlines and countries. And that's the end of my presentation. So I really appreciate everyone listening in. I know we're going to do some Q&A here in a second if there's any more questions. I love fall foliage. I know everyone in this group listening tonight does. So I just really appreciate y'all learning more about the science with me. And I really appreciate the invite from Weatherband as well to chat about all this fall foliage goodness.
Well, thank you, Evans. Thank you very much for sharing your time and your work and your talents with us. Very much appreciated. That was really cool, and I definitely got sucked in there. So I was wondering, Evan, I did have a couple of questions for as you went through. I was wondering, is there, in your experience with working with leaf change and everything, has there been any noted influence of climate change or any weather issues like that?
Yeah, not that I've seen. Obviously, I've been doing this for 2 years, so I don't have as much experience as some of the foliage experts. There's a couple of guys in the Northeast that have been reporting on foliage for decades. It's really impressive. But I can certainly hypothesize to it a warming climate, especially if we begin to see these warmer nights, which has been so evident across the United States. These warmer nights are not good for fall foliage. So we need those cooler nights to trigger the downfall of the chlorophyll and the production of the anthocyanin. And without those cool nights, we'll likely see duller colors. Again, this is all just conjecture, but that seems to line up. That's certainly what we see in instances of a warm fall. Sometimes, obviously, not all warm falls are correlated with climate change. So we just have warm weather sometimes. And when you see these warm periods, like will become more frequent in the future, particularly those nighttime lows, when they become warmer, it has a negative impact on the intensity of the fall foliage. As for the timing, I think that will fluctuate. Obviously, if you're in a location that will be warmer, there'll be later peak colors, later timing on the peak color. I would also say that drought and increased rain will have an impact on it. That's going to vary across the entire globe. Obviously, there's no unanimous decision to, it's going to be a warmer globe, or it's going to be a drier globe. But yeah, all of these things will come into play.
Oh, excellent. And another question, Evan, is there a tracking, like foliage tracking service in other countries as well?
Ooh, I was just chatting about this the other day with Kyle from the Foliage Report. The only one that I'm familiar with is AccuWeather actually put out a forecast, a fall foliage forecast this year for Europe. I'm not sure if that's something they've done in the past, but it's the first time. It's new to me, at least. So AccuWeather has an interest over there. The United States is somewhat unique in that we have some of the best fall color in the world because of our deciduous trees. You also see that in Europe, and you see that some in Japan as well. So fall color is not just limited to the United States, but from a reporting system, I'm not aware of any others on a national scale. I'm certain you could find some local ones in Europe. You may have to do some language interpretation and may deal with some language barriers there depending on the country. But AccuWeather, as far as I know, is at present the only one with an overseas interest, and they may produce reports that'd be worth looking into.
Oh, excellent. Good to know. Good to know.
Yeah.
And then Janet asked a question here, Evan. Janet asked, what kind of change would happen if you have a cold/cool spell of weather and then a warm spell?
Yeah, so we would start to see, with that cool spell, you would see the leaves, the trees begin to prepare for winter. So they start shutting down the photosynthesis machine, and then they start to produce that anthocyanin in those reds. What would happen if you suddenly had temperature whiplash and had hot weather afterwards? You would see the color change stall out. It started to change in that cold weather, but then it would stall throughout that the duration of the heat episode. We saw that happen last year here in Western North Carolina, where the leaves were changing early and we were on track for a great fall foliage season. And then we had a long stretch of rainy and wet weather, and the leaves just kind of hung in the balance where they had started to change, but they just weren't there yet, and they weren't changing anymore. So all it does is delay that timing of the peak color.
Gotcha. Good deal. And then another question, and this kind of steers more towards biochemistry, Evan. So,
Sure.
just out of curiosity, though, are the tree pigments that you spoke of? So there's chlorophyll, and there's the anthocyanins, and then there's the other two that I forgot. Are they similar in chemical structure? And then is there something about chlorophyll that just makes it more expensive to maintain?
Yeah, that's a good question. That's definitely outside of my my understanding of foliage. There's some biologists out there that could lead you in the right direction. Those other two, I'm realizing, I think I forgot to mention, I'm not sure I mentioned their names, the carotenoid and the xanthophyll. Those are the ones that produce the yellows and the oranges.
That's right.
As for the unique composition of each, you would have to ask a biologist. This meteorologist is not certain.
No worries, Evan. Yeah, no worries at all. Yeah, just curious. No, thank you. All righty. So I think that kind of wraps up the questions that we got from the audience.
Yeah.
So yeah, I guess Melissa, did you have anything
I
to
did. I did see one last question. Sorry, I'm fighting laryngitis. And this goes back to Zara put this in, talking about the climate change aspect again. Is there would you see different trees maybe migrating north, which would also change the colors that you might see in certain areas because there are the hardiness zone changes?
Yes, that's an excellent question, and actually something I hadn't considered before. So I'll come up with my answer on the spot. But yes, you will absolutely see these different types of trees moving north and some moving south. Maples are a staple here on the East Coast, and I think we'll see the zones for that begin to shift north with time, perhaps even into Canada. Oaks as well. Oaks have a unique kind of rusty color, and they're not quite as widespread across the northern tier as they are down here in the south. I believe we'll begin to see those shift north as well. Oaks are unique as well. I didn't mention this in the presentation, but I think it's worth noting here because I found it really fascinating the past couple of years. Oaks have on average, at least here, this is my personal observation in the Southern Appalachians, a different peak timing than the other deciduous trees. So the maples tend to go first. You'll notice those in the parking lots, and then you'll notice the healthy maples that aren't in parking lots turning next, and then you'll see the oaks turn later. In some seasons, we actually see a distinct peaks, between the maples will be peak color, and then there'll be a dip in overall color, and then you'll see the oaks reach peak color. So there's a lot to consider in how there may be constructive and destructive interference or destructive interference between all these different types of trees.
Oh, excellent. Yeah. Thank you for pointing that out too, Melissa. And okay, I think yeah, that's all that we have for now, Evan.
Awesome.
Yeah.
Great.
Well, thank you
Super
so
fun.
much thank you so much for sharing your time and your work with us again. And Melissa, thank you for contributing as well. Folks, I think yeah, we've answered the questions that you may have, and that looks like that's all the time that we have for today. We will make this video available to weatherband members at amsweatherband.org, and members are welcome to discuss on the Weatherband Community Forum. We have started a thread for you to post about fall foliage in your area, folks. So if you look, let's see, and I think it should have just gone live right now. If you look at our community forum, you'll have an opportunity to share out any pictures that might be interesting in your area. And members can go to community.amatsoc.org/weatherband and record your observations for this season. So yes, I guess that concludes our presentation.